Hello, my name is Ali Sekmen. I'm a professor of computer science at Tennessee State University. Welcome to ENCS 6010 Advanced Applied Mathematics. I will be teaching this class with Dr. Erdem Erdemir this semester. I hope you enjoy it. I'm going to talk about the contents of the class with you today. Well, the first week we are going to talk about mathematical spaces. We are going to have a comprehensive introduction to available spaces. We'll talk about norm vector spaces, inner product vector spaces. We'll talk about Banach and Hilbert spaces. We will introduce metric spaces, and we are going to touch to topological spaces as well. Well, inner product spaces is based on the concept of angle between the vectors. And then norm vector spaces are based on the concept of length of a vector. And metric spaces, the main concept is the distance between vectors. And topological spaces, there are some spaces, some topological spaces in which you cannot define the distance, but yet you can still define how close the points are. So basically topological spaces are based on closeness or nearness concept. And we are going to also introduce certain concepts from real analysis, like convergence. We'll talk about Cauchy sequences and Cauchy convergence. We'll talk about closed and open subspaces. In fact, we are going to introduce a subspace in lecture 2, and we are going to talk about their properties. We are going to talk about orthogonal subspaces, complementary subspaces, linearly independent subspaces, disjoint subspaces. We will define a metric to measure how close the subspaces are that will depend on the principal angles and the distance between subspaces. And lecture 3, we are going to give fundamentals from linear algebra. We are going to have a review of eigenvalues, eigenvectors, matrix decompositions. We are going to specifically focus on singular value decomposition, which is an extremely important decomposition. You are going to see that principal component analysis, which is heavily used in machine learning, is a simple application of singular value decomposition. We will talk about subspace segmentation problem. We are going to show that motion segmentation or facial expression recognition are special sub-problems of subspace segmentation. We're going to talk about spectral clustering and different algorithms that are heavily used for clustering data that comes from union of subspaces. And lecture 5 is going to be an overview of differential equations and its applications to certain engineering and science problems. It's going to be kind of review, and that will be followed with lecture 6. It will be mathematics of deep learning. Many of you are familiar with deep learning or deep convolutional neural network, and many people apply heavily in different areas successfully. It's very successful, but not many people really fully understand the mathematics behind deep learning. So we are going to introduce what convolutional neural network is and how it acts as a feature extractor, and then a fully connected neural network cascaded to convolutional neural network, and fully connected neural network acts as a classifier. So we are gonna show that the features generated by a convolutional neural network simply create subspaces, and those subspaces can be segmented by the fully connected neural network. So we'll have a good understanding about mathematics of deep learning. We will have numerical methods introduced, and we'll talk about very important concept, convex optimization. Convex optimization is good in the sense that if there's a solution that corresponds to a global solution compared to non-convex optimization, and we will see if we can identify if a problem is a convex optimization problem or not, and what are the available tools for us. Fourier analysis is heavily used in many areas of engineering and science and mathematics. I am sure many of you are already familiar with it. A Fourier transform basically takes us from time domain to the frequency domain so that we can do certain analysis that we cannot perform in time domain. We'll also talk about some other concepts such as short time Fourier transform that takes us to the frequency domain without losing time domain information completely. There's a new concept called, it's not new, but not known to many people, a fractional Fourier transform. We'll also introduce that concept very briefly. And of course, we're going to have certain concepts from discrete mathematics, such as sets, functions, relations, and how they are applied to databases. Specifically, we'll talk about first order logic. We'll introduce some concepts from graph theory there. Probability and statistics is important. We will introduce the concepts of probability, uncertainty modeling. We'll talk about different distributions, probability distributions, and how heavily they are used in different areas. It's gonna be kind of introduction. And last week, we planned to introduce you to abstract algebra so that you understand the concepts from abstract algebra, such as fields, groups, rings, and so on. We don't expect that you're gonna be, an expert in that area, but we want to expose you to abstract algebra as much as possible. Again, as I said, this is a fun class. I hope you enjoy it. Please feel free to communicate with me or Dr. Erdemir if you have any questions. It's going to be a fast semester, and we are hoping that the concepts that we are going to discuss here will help you with your PhD work at Tennessee State University. Again, have fun.